So our next lesson is entitled Negative and Zero Exponents. And the good thing about this lesson is your vocabulary is not brand new at all. This is probably the third time you've seen these words, but they do bear repeating. Let's go over them very quickly. We have a power, and you know that a power, when you see power, it means it's one large number and a tiny number, and it means it's a multiplication expression where it's repeated multiplication of the same factor. The exponent is a small number in a power, and it tells you how many times that factor is going to be repeated in the multiplication expression. And then finally we have base, which in a power is the larger number. It's the number that is the factor. It's the number that gets repeatedly multiplied for as many times as the exponent says. Now, before we get into our 4 examples, I want to show you one board that has 2 rules of exponents. This first one, if you can see it, is x to the 0 power equals 1. So no matter what the base is, if it's raised to a power of 0, it has a value of 1. And I want to show you, using division, why that is. If you remember, when we are dividing, let's just say we have 3 to the 2nd power divided by 3 to the 2nd power. And you know from the previous lesson that when you are dividing powers that have the same base, what you do is you keep the same base, and you have 2 minus 2, which is 0. And that's all well and good. But a better example of this is to show you in an expanded form. So if we have 3 to the 2nd power divided by 3 to the 2nd power, what that means is 3 squared is 3 times 3 divided by 3 times 3. And what happens is that when we show the expanded form, you can see that this 3 over 3 makes a 1, because you remember that, and when the numerator and the denominator are identical, their value is 1. So I'm going to put a 1 here and a 1 there. And here we have another 3 over 3, and that's a 1, and that's a 1. And then when we finish it up, we end up with 1 times 1 equals 1, 1 times 1 equals 1, which simplifies to 1. So before, when we did the shortcut, where we kept the base 3 and subtracted the 2 exponents, 2 minus 2, which is 0, 3 to the 0 power equals 1. And I think the expanded form is a really good way to illustrate that. And then here, our second rule is x to a negative power, we're using the letter n, means that this x with the power gets moved to the denominator of a fraction, where in the denominator we keep the same exponent but in the positive form, and the numerator will be 1. And as we work through our 4 examples, this will become more clear. So let's take a look at our first example. Write the expression using positive exponents. So here we have 5m to the negative 2. And just a reminder, this negative 2, this exponent is anchored to the variable m. It has nothing at all to do with the 5. The 5 here is really just a coefficient. But we're going to take this one piece at a time. Let's take a look at the 5. When we are going to move this into a fraction, this 5, which means 5 over 1, will get put into the numerator. Now we have our m to the negative 2 power. If you remember from the board right before this, what we do is we move it to the denominator. There's our m, and we keep the number in the power the same, but what we do is we write it in the positive. So using only positive exponents, 5m to the negative 2 becomes 5 over m squared. Let's practice that with this example. Here we have a to the negative third power, b to the positive 2. Because we like to work left to right, we'll start with the a to the negative third. And we're going to do to the a to the negative third exactly what we did up here with m to the negative second. This gets moved to the denominator of a fraction. So we have a, but this time the exponent will be written as a positive, so this negative 3 becomes a positive 3. And this b squared, because it's a positive exponent, gets put into the numerator. So a to the negative third times b squared becomes b squared divided by a to the third power. All you have to remember is when you have a base with a negative exponent, we take that piece and we put it into the denominator of a fraction. If there are no other pieces with it, no coefficients, no variables with a positive exponent, then the numerator is simply 1. Now we have our second example. Here we're going to work backwards. We're going to do the opposite of what we did in the first example, because we are going to write these expressions without using a fraction bar. Let's take a look at the first part. We have 1 over 25. Now, I don't see any exponents. So what we're going to do is we are going to change this to 25 is the same as 5 to the second power. Now that we have an exponent, we have to consider what to do. If you think about what we did in example 1 and in the boards before that, you know that when we have 1 in the numerator and a power in the denominator, it means this power is actually a negative power, negative exponent. So 1 over 5 squared means that it's 5 to the negative 2 power. So if you remember what we did before was we would start with 5 to the negative 2 power. And we would take this and know that this negative exponent meant we would need to open up a fraction bar, move the power into the denominator, make the exponent positive, so here 5 squared, and we would put 1 in the numerator. And now we're going to do the same thing here. Here we have 7 divided by p to the 4th power. So here's what we do. Since this is already with an exponent, we don't need to follow this step. This will just be one step to complete it. This 7 in the numerator gets moved over. It doesn't change at all. The only difference is there's no fraction bar now. And here, this p to the 4th power, because it's sitting in the denominator of this fraction, it tells us that without a fraction bar, its value is, or it's expressed as p to the negative 4th power. So again, what we did here was we were working backwards from what we did in example 1. And here we have example 3. We're going to find a product, and it's here, the directions are key. You're going to write your answer using positive exponents. So here what we're doing is we're taking what we learned in the previous lesson and applying it here with negative exponents. What I see here is 8 to the 5th power times 8 to the negative 7. So right away we're recognizing that our base number is 8. So we move the 8 over. And if you remember from the previous lesson, rules of exponents, when we are multiplying powers and the base numbers are the same, what we do is we add the exponent. So what this becomes is 8 to the 5th power to the 5th plus a negative 7. And when we simplify that, because it's 5 plus a negative 7, our base always stays the same. 5 and a negative 7 mean it's a negative 2. But if you look at your directions, it says we are only allowed to use positive exponents, which means we have to open up a fraction bar. This 8 to the 2nd power gets moved to the denominator, but we change this negative 2 to a positive 2. Since there's nothing else with this power, the numerator becomes 1. So 8 to the 5th times 8 to the negative 7th power equals 1 divided by 8 squared. And let's take a look at this problem. Here we have 6a to the negative 2nd times 5a to the negative 10th. Now remember, this exponent and this exponent are anchored to the variable a. They have nothing to do at all with the 6 or the 5. And when we have a case like this, what we do is we multiply the exponents. Remember, as I say in class, whenever we have a monomial, we have to look at it in separate pieces when it comes to the exponent. So when we work left to right, our first piece are our coefficients. Positive 6 times a positive 5 give us a product of a positive 30. Now what I'm going to do is we're going to work with our variable powers. So what we do is we attach our variable a, which is our base. We're multiplying them, which means we have to add the exponents. So it's a negative 2 and a negative 10, which gives us 30a to the negative 12th power. Now once again, refer to your directions, and this tells us that we are only allowed to use positive exponents. So when we have a negative exponent, it means we have to open up a fraction bar. And again, just as I said before, we take this one piece at a time in isolation. So we're going to start with this 30, this coefficient. Anytime you have a coefficient with a power that has a negative exponent, the coefficient goes into the numerator. And then this next piece, this a to the negative 12, well, we move the base a to the denominator. And instead of having it raised to a power of a negative 12, sitting in the denominator, it becomes a positive 12. So our product of 6a to the negative 2nd power and 5a to the negative 10th power is 30 divided by a to the 12th power. And we have one more example. So once again, we have a case where we are taking what we learned in the previous lesson and applying it to negative exponents. Here we are going to find the quotient. You know the fractions or division problems. And when you have powers in a fraction, you have to subtract the exponents. Our base, we have 3 squared divided by 3 to the 8th power. Right, the first thing we write is our base 3. And because we're dividing, as I said, we're subtracting the exponents. So this becomes 3 to the power of 2 minus 8, which we will simplify to be 3 to the negative 6th power. Now we're only allowed to use positive exponents, which means that since we have a negative exponent here, we have to open up a fraction bar. And that's key. That's good for you to remember. Whenever you see a negative exponent, open up a fraction bar. Now because this power is basically by itself. It has no other coefficient. It has nothing with it. It means our numerator is 1. And then this 3, this base number gets moved to the denominator, and we take our exponent and put it in its positive form. So that what we end up with is 3 squared divided by 3 to the 8th power has a quotient of 1 over 3 to the 6th power. And now what we're going to do before we finish is do our next part where we do have coefficients and powers. And just as we did before, we're going to look at this in separate pieces. We have a 24 being divided by 12. Got a little ahead of myself. 24 divided by 12 is 2. And remember, we are going to then attach our base y. Our numerator has an exponent of -2. Our denominator has an exponent of -4. And as I say in class, here is where a mistake might occur. You already know that when we're dividing exponents, when we're dividing powers, the rule is that when the base is the same, we subtract the exponents, numerator minus denominator. And so, when I refer to where a mistake might happen is right here. Oftentimes, when a student sees a negative number as the second number in a subtraction expression, they think that that negative will replace the minus sign, and it doesn't. So here's how I like for you to write it. We have a -2, then we put in our minus sign for the operation, and then in parentheses we put our -4. Because there is a big difference between a -2 minus a -4, and then just a -2 with a -4 next to it. Then we simplify this, and we have 2y. A -2 and the opposite of a -4 means we have a -2 and a +4, which gives us a positive exponent of 2. And when you have a positive exponent, there's no need to open up a fraction bar. That would only be if this were negative. Now, there's a lot of information in a short lesson. I don't expect you'll have a very deep understanding, but when we go over this in class, this will be familiar and it'll gel together better for you.